In Trig, we are going to cover lesson 56, and it's kind of long. There are 3 big parts to this section. I'm not quite sure why they make some sections so short and others so long, but this lesson is long. So 56.A goes over triangular areas. I've written the formulas in case you've forgotten for both. So area of a triangle is base times height divided by 2, but remember that your height is the side that is perpendicular to the base. Area of a trapezoid, trapezoids do contain triangles, so you'll see that in this section, and so I've written the area here. So let's get started. We're going to do a couple examples. So make sure in your homework that you actually draw the information that they've given you. All right, so here is my triangle. Has a base of 16 inches. Here would be the height. This side is 12 inches, and this here is 42 degrees. Find the area of the triangle. So notice you'll see the word area and then a subscript of what you're looking for, and that'll be useful for 56.B. So anyways, in this triangle, I need to find height. So in order to find H, or to find the height, right, H would be perpendicular, so it's this segment here that is perpendicular to my base. So in order to find that, right, I would do the sine of 42 degrees equals height over 12, and then I would cross multiply. So 12 times the sine of 42 degrees equals height. So height equals, based on my calculations, 8.03 inches. So now I can find the area. So the area of the triangle would be 16 times 8.03 divided by 2. And I get, for that, I have 64.24 inches squared. So first find the height, and then find the area of the triangle. So I kind of did that backwards, right to left. Next one. All right, so this is 6 meters. This angle here is 150 degrees, and this side here is 14 meters. And so they'd like us to find the area. Of our triangle. So the first thing I need to do, right, step 1, is I need to find our height. And so it should be perpendicular. So the height of this triangle should actually be this here. And I'm going to go ahead and zoom in just a little bit. So this would create a 90-degree angle. So let's look at what I have. I have my hypotenuse of 14. I know that if this is 150, then this here is 30. So I know the sine of 30 degrees would equal my height over 14, right? Because opposite in hypotenuse is sine. So 14 times the sine of 30 degrees equals my height. So I found a height of 7 meters. So if my height is 7, then the area of my triangle would be 7 times 6 divided by 2. That gives me 21. So 21 meters squared. Last one, and then we'll move on to 56.B. So I'm going to give you a trapezoid, which is why I covered the area of a trapezoid. And so the bottom is 10 meters, the top is 4, and this side right here is 5, and this here is 29 degrees. They'd like us to find the area of our trapezoid. right? Which is, I reviewed it above, which is the sum of your bases, doesn't matter which base you write first, times your height divided by 2. So I need to find my height, which would be here. So I'm going to find my height, which would be the sine of 29 degrees equals opposite over hypotenuse. So my height equals 5 times the sine of 29 degrees. So if you input that, I got that my height is 2.42 meters. Now I can find the area. So the sum of my bases times my height divided by 2. And I got 16.94 meters squared. So that is 56.A, which I'm sure you'll do fine in because it's area of a triangle. All right, so next is 56.B. So we're going to change it up a bit. Now we're going to be finding the area of segments. So I'm going to go over what they mean. Here's a circle. Okay, now area of this segment is referring to this part right here. And so it is the segment that is bound by this here is an arc, right? And right here, this would be a chord. This right here is my central angle. So let's go over a couple things. I have the area of my segment, so the area of our segment is equal to the area of our sector. Remember, sector is a slice of pie. So this is a sector, or think of it as a slice of pie. So that's the slice of our pie minus the area of our triangle. That is how I would find this portion highlighted in orange. Okay, so a couple things about this. We are going to have to find our height, and we will be dealing with our radius. So height will be, and if you notice in the last couple, height was always our hypotenuse times the sine of our angle. So in this case, my hypotenuse is the radius. So radius times the sine of whatever theta is, which is this angle here. Okay, so you have all these working pieces. Let's go over the area of a sector. Remember, a sector is a slice of pie. So in order to find the portion of the area of that portion of a circle, it would be whatever our theta is, or our central angle, divided by 360 times pi r squared, right? Because this is area of a circle, and then this will be the angle of that area that has been shaded. So we're going to practice a couple. So number 1, and I believe these are mostly word problems, so then we're going to take the word problem and convert it into a picture. So find the area of the segment bound by the arc of 45 degrees and the chord joining the endpoints of the arc, and the radius of our circle is 6. So this section, 56.b, I don't believe they give you really any pictures. They ask you to draw a picture from the word problem. So let's picture our circle. And it doesn't really matter if the segment is over here or over here or over here, right? It doesn't matter where it's located. But I do know that my radius is 6. And this would be 90, so 45 is probably right here. So they've told me this is 45, and here is a chord. So they want the area. They want the area of that segment. So remember, it'll be the area of our sector minus the area of the triangle. So let's first find the area of our sector, so that'd be 45 over 360 times pi 6 squared. Okay, so 45 over 360 is reduced to, I believe, 2, 4, 6, 8. Hold on. 360 divided by. So this equals 36 over 8 pi. I'm going to go ahead and make it a decimal because I'm going to need this as a decimal because I want to find my final area. Or you can leave things in terms of pi. It's up to you. I reduced this to 1 over 8 and then the 36. But as a decimal, this would be 14.14 inches squared. I didn't say inches, but let's just pretend. There. And then now I'm going to find the area of my triangle. But in order to do that, I need to find my height. Now let's talk about my height. So height, I know if this is 6, then so is this. So it would be 6 times the sine of 45 degrees equals my height. And 6 times the sine of 45 height is 4.24 inches. So the area of my triangle is 6 times 4.24 over 2, which just means this is 3 times 4.24, right? 6 over 2. And 3 times 4.24 is 12.72. And so the area of our segment is the area of our sector minus the area of our triangle. So 14.14 minus the 12.72, I got 1.42 inches squared. Or you can put units squared if they didn't give us inches. Okay? Now you can, I would not leave my answer in pi because the area of a triangle was not in pi. So and I didn't think about that when I first said it. So convert it to a decimal. We'll do one more because we need to talk about if it's not in degrees. So find the area of segment formed if there is a central angle is 0.8 radians and our radius is 10 feet. So again, I'm picturing this circle. I know this is 10 feet. It says 0.8 radians, so I don't know the degrees. I just know, I'm just going to make this up. So this is, I don't know the degrees yet, but I'm looking for this here. So the area of our sector, I have 0.8 radians, right? Now, I need to convert this to degrees, so I'm going to divide by 2 pi. Because this is 360, it's just in radians. You can see that. Instead of theta over 360, I have radians over 2 pi, because pi is 180, so 2 times 180 is 360. And then that times pi 10 squared. Now, in order to find the height, I'm going to put my calculator in radians to do the next part. It would be 10 times the sine of 0.8 radians. So in your calculator, mine is currently on degrees. Okay, if I want to change that, there's a DRG, and then I can go to radians, and then I'm able to find 10 times the sine of 0.8, and it gives me 7.17. So I got 7.17 feet. So now that I have, this is my height, so the height equals 7.17 feet, I can now find the area of our triangle. So 10 times 7.17 divided by 2 gives me 5 times 7.17. And so I'll simplify both of these. So for the area of a sector, pi cancels. And so I have 0.8 divided by 2 times 10 squared. And that gave me 40. The area of a triangle, 5 times 7.17, gave me 35.85. So the area of my segment would be 40 minus the 35.85, and I got 4.15 feet squared. And it's squared, right, because it's area. So that is 56.B. I now need to go over 56.C, which, hold on, has to do, I'm going to write it here, 56.C has to do with systems of inequalities. In Algebra 2, your inequalities usually involved two lines, not in trig. You're going to have lines and circles and parabolas. So inequalities, you're going to have two inequalities, and those two could be linear, quadratic, circle. I think you even get an ellipse. Okay, but you're going to have two. So first I want to go over how we can shade, how we can find the region, and then we'll do it by hand. So here is, we're first going to go over how to find the area in which they're shaded, which is very similar to your homework. So I'm going to start with the top, and I'm going to give you two methods. There are two methods for shading. The first method is to test a point. The easiest is 0, 0, but you can test any point. Method 2 is greater than, you shade above, and less than, you shade below. If y is by itself. So I'm going to do both methods. So first I'm going to test 0, 0 for this line. So is 0 greater than or equal to 1/2 times 0 minus 4? That leaves me with 0 is greater than -4, which is true. So since I'm testing this point, and I know that based on the form mx plus b, I know this is my line. Because of that x squared, I know this is my parabola. So for the line, since that point was true, I'm going to shade above the line. So I'm testing this point right here in pink. My other method of it being greater than would mean I would shade above the line because y is by itself. Now let's try the parabola. I'm going to test 0, 0. So is 0 greater than or equal to negative 0 squared plus 4 times 0 minus 1? Well, that gives me is 0 greater than or equal to negative 1. That is also true. So I'm going to shade, you either shade underneath your parabola or you shade above your parabola. Those are the only two options, right? With a line, it's above the line or below the line. With a parabola, it's either on the outside or underneath or inside. And in this case, since 0, 0 was true, I'm shading on the outside. The other method would be to look at both of these, and since both are greater, I shaded above. Okay, now the region in which the answer is where the shading overlaps. So in this case, region A, both red and blue overlap. Okay, so let's try that here. So for the top, this is above. Now, this is your parabola based on x squared. This is your line. So if I'm looking at my parabola and this is greater than, I would shade above. So you have to ask yourself, is above inside or outside? I know it's inside, but to confirm, I'm going to test that point 0, 0 again. Now I can test that point because neither graph lands on that point. It's also the easiest. You can also test 1, 1, 1, negative 2, 3, 3. You can test any point in the world. So I'm going to test 0, 0. So is 0 greater than or equal to 0 squared is 0 plus 4 times 0 is 0. Is 0 greater than true? Is 0 greater than 2? That's false. So 0, 0 doesn't work. So I'm not going to shade where 0 is, which would be on the underneath the parabola. I'm going to shade on the inside. So if it's true, you shade where that point is. If it's false, you shade elsewhere. Now I'm going to do the same. So is 0 less than 1? Yes. So I am going to shade where 0, 0. It's also less than, so shade below the line. So remember, this is for the line. I have both methods. 0, 0 works, so I'm shading where 0 is. Or you can think I'm shading below the line because it's less than. Either way, the region in which the shading overlaps is region C. Number 3. Whew. This is a circle because both are squared and there's an invisible 1 in front. The bottom is our line. So let's start with our circle. I'm either going to shade inside the circle or on the outside of the circle. Those are my only two options. So I'm going to test 0, 0. If 0 is true, then I'm going to shade inside the circle. If 0 is false, I'm going to shade on the outside of my circle. So is 0 squared plus 0 squared less than or equal to 16? That is true. So I'm going to shade on the inside because I just found that that point works. Now the line goes right through 0. So it wouldn't be smart to test 0, 0 because it's right on the line. Now it does say greater than, so for a line I would just shade above, but I'm going to pick a point, and you can't pick a point on the line. So I'm going to pick negative 1, 1, okay? Because that is not on the line. So if I'm plugging in 1 for y and negative 1 for x, this is true. So I confirmed that I would shade above the line because it's true. It's also a greater than, I could have just shaded above. So that would mean that region B, the shading overlaps. So that is if they give you as a problem like that. I also need to teach you how to do it by hand. So we are going to graph and shade regions that satisfy inequalities. Now, you guys have Desmos, so you could enter both of these in Desmos, or you can do them by hand. It's up to you. So number 1, y is less than or equal to x plus 2 squared, and the bottom, y is less than or equal to negative x plus 1. Now, I told you this section was long, so hang in there with me. I'm going to grab a couple things. So this first one is a parabola. My vertex is negative 2, 0. I know that because k out here is 0. So I'm going to quickly draw an x and y axes. I know that the graph points up because A is 1. So you could use Desmos if you prefer, and you would type just that y. You can put y equals x plus 2 squared. It's up to you. But I'm going to do it by hand. So in red, my vertex is at negative 2, 0. A is 1, so if x is 1, 1 unit to the right, 1 squared is 1, so I'd go up 1. Starting at the vertex is x is 2. Remember, this is my x-axis, so 1, 2. 2 squared is 4. And that's all I need. This is my axis of symmetry, so I'm going to reflect my points across. Now I'm going to test 0, 0. So is 0 less than or equal to 0 plus 2 squared? 0 is less than 4. That's true. So I would shade where 0, 0 is. All right, the bottom is a line. I shouldn't have to tell you how to graph a line. My y-intercept is 1. My slope is negative 1. So here is my line. That is less than. So I'm going to shade below. And I'm going to shade. Notice I didn't shade in the parabola. So I want to be able to easily see the area. You can, but I want to see the areas in which they overlap. And they overlap right here. Next one, and how many do I have on here? I have a lot because I want you to be able to do these easily. So the next one, graph y is greater than or equal to x squared minus 1. And y is less than or equal to 3 minus x squared. Super important. I will go over this one because this looks, I've done all the homework in all your lessons, and so I know you're going to get one that looks just like this. So here's 2, 4, 2, 4, negative 2, negative 4, negative 2, negative 4. Here's x, here's y. All right, so I'm going to do this one in red. So this has a vertex of 0, negative 1 because the parent function is at negative 1. And I know based on that it points up. So if x is 1, go to the right 1. 1 squared is 1, so up 1. If x is 2, 2 squared is 4. And then reflect it across. I'm going to test 0, 0. So is 0 greater than or equal to 0 squared minus 1? Is 0 greater than or equal to negative 1? That is true. So I'm going to shade above. The bottom, I'm going to rewrite this. So y is less than or equal to negative x squared plus 3. That means it points down. And my vertex is at 0, 3 because this just means the graph has been shifted up 3. So up 3. It points down, so if x is 1, 1 squared, go down 1. If x is 2, go down 4. I'm going to reflect those across. You can also use Desmos if you don't like my shortcuts. Test 0, 0 is 0 less than or equal to negative 0 squared plus 3. 0 less than or equal to 3. That is true. So I'm shading where 0, 0 is. So I'm shading below. So I hope you notice that this section here is where the shading overlaps. So you're just going to get a million different versions of that. So hopefully you're okay with it. If not, I can help you if you have any questions on your homework. Which, speaking of homework, I know this video has been long enough. So homework 56, skip numbers 7, 8, 23, 24, and 27. Thank you.